Aloha and welcome. In this video, we're going to be talking about endpoint hardening. Specifically, we're going to be talking about disk, registry, ports, and services. So the first thing we're going to talk about is our hard disks. So on an endpoint, you've got a disk. That disk is usually partitioned with one or more volumes, and you can harden your endpoint by having data encryption on your hard disk. And we've got two different types of disk encryption that we're going to talk about. We're going to talk about FDE, which is full disk encryption, and we're going to talk about SED, which is self-encrypting drives. So full disk encryption, it's a method of securing your data using encryption, and it can be implemented in either hardware or software. So remember, FDE can be either hardware or software. So FDE encryption, you're going to create an encryption key, and you're going to create that from some kind of a token or a user password or PIN, something like that. So you're going to generate this longer key that you're going to use. So an example of this is in if you've used Windows since, gosh, anywhere in the last 10 years or so, you'll be familiar with BitLocker. So BitLocker is a security feature that uses software or hardware-based encryption to protect the drive data. So it's going to store the drive encryption key in a TPM module, the trusted platform module, that hardware piece that's on the computer, inside the computer. And you can also store that encryption key. If you don't put it on the TPM, you can also put it onto a USB drive somewhere externally. And BitLocker uses AES in cipher block chaining mode with either 128 or 256-bit keys. So remember that BitLocker uses AES and CBC mode with 128 or 256-bit keys. The other type we're going to talk about here is the self-encrypting drives. So self-encrypting drives, that's a hard disk or a solid state disk, SSD, with encryption circuitry built into the drive itself. You don't have to worry about software to handle it or anything else. All the functionality, all this encryption functionality is built into the hard disk itself. So SED, it's a special form of FTE that uses only the hardware-based encryption. So SED is going to be transparent to operating systems, applications, and users. Is designed to automatically encrypt and decrypt the drive data without the need for disk encryption software. So SED uses AES with the 128 or 128 or 256-bit keys as well. So it's just like BitLocker in that sense. So the SED encryption key, it's factory set and it's stored on the drive controller itself. And again, it's invisible to the operating system. It's fully contained within that drive itself. um, so moving on from that, we've got something called Opal, and Opal is a set of security specifications for SED, and they define the hierarchy of security management standards that secure data from theft and tampering by unauthorized persons. So the specification is published by the TCGSG or SW, which is the Trusted Computing Group Storage Work Group. So Opal is used for applying hardware-based encryption to storage devices such as hard disks and solid-state drives and optical drives as well. And one thing to keep in mind is an Opal-compliant SED requires that the user to authenticate upon unlocking the system, at boot up time. So we're also going to talk about the registry. So in a Windows system, you've got something called the registry, and the registry is where you're going to be storing all kinds of configuration settings. So different parts, well, not just different parts of the system, but also third-party programs are going to be accessing this to store configuration settings. So the kernel is going to access it, device drivers, your services, your security accounts manager, what we call SAM, and also the third-party programs. They can use the registry to store information settings. So in there, you're going to find user passwords and file permissions, types of documents an application can create, and lists of recently open files, to name a few. So this structure, it's kind of like a tree structure. It's a hierarchical structure, and there's many different sections and subsections and sub-subsections in there. And each one, when you finally get down to the bottom of it, you've usually got some kind of a key and then a value for it. So one thing that we need to do in hardening these endpoints is we need to make sure that people can't modify these registry settings. So in the group policy object, known as a GPO, you've got this setting called user configuration slash administrative templates slash system slash prevent access to registry editing tools. And I have a graphic of this in the reading, but if you go in there, you can set policy on that. So you can set it to enabled in order to prevent people from accessing the registry. Usually it's through your administrative privileges that you're going to get access to the registry. So when you have when you have that ability, you can use something like regedit, or I think it's regedit 32, something like that, to get into the registry settings and make modifications. But this is very dangerous to do because if you screw up some of your settings in here, you can really alter the way your system runs. You can introduce all kinds of buggy behavior and everything else. So even if you're not thinking about a security standpoint, worried about people breaking in, you also want to prevent against accidental modification, or somebody that comes in, maybe they're a power user, like, oh yeah, I need to get a little bit more performance over here, so I need to tweak this little setting. And they go in, they tweak a setting in the registry, it can corrupt things and make things run strangely. So you don't want just anybody accessing this. So keep that in mind. So another thing we need to worry about is open ports and services. When we talk about hardening a system, we've talked about disabling services that aren't being used. So we need to talk about open ports and services here. So an operating system port is a 16-bit unsigned number that uniquely identifies a network application or service on a host. That number is going to be between 0 and 65,535. And a port can be one of three types. It can be a well-known port. We've talked about well-known ports before, like when I tell you, hey, you're going to need to know that TCP operates on, or not T, FTP operates on, TCP ports, 21 and 23 or something like that. And when I mention this to you, uh, you're going to need to go in there and you need to memorize these. So one thing that you can do is take a look. You can do a simple web search on common ports. So I'm doing this as I speak. So if you go into Google and you just type in Google ports, you'll be able to find a list of common ports. So I'm going in and I'm just typing in common ports here, and it comes up with the common ports. And I misspoke a second ago when I said FTP works on 21 and 23. It's 20 and 21. One is your data and one is your control. So keep that in mind. But if you just type in common network ports, you'll find a list of them. And this is a great list that the AI overview that I get is really good. 2021 for FTP, SSH we talked about is 22, SMTP, which is the Simple Mail Transfer Protocol, that's 25, DNS is 53, HTTP is 80. We've also got secure on 443, POP3 is 110. And so you've got all these different port numbers that are going to come up, and the ones I see here are the ones that we've actually covered and you'll need to know. But what you need to know in this lesson essentially is that when you're talking about that range of port 0 to 65,535, the well-known ports are the ones between 0 and 1023 that are reserved for commonly used services. So, and the example they give is TCP port 80 is HTTP. And then we've got what we call the registered ports. So above the well-known ports, the next segment from 1024 to 49,151, those are port numbers that you can register with IANA, which is the Internet Assigned Number Authority, and you can assign it for a specific use. So for example, TCP 3389 that I've mentioned in the past, that's used for RDP, for remote desktop protocol from Windows. So they registered that port to be used for it. Anything that's above 49,151, we call that the higher number ports. We call those the private ports or dynamic ports, and those can be used by any application. You can use that however you like. So keep that in mind. So we've got all these ports. We've got the well-known, the registered, and the high number ports. When we talk about an open port, an open port is a port that is configured to accept data packets. It's open and listening for packets. Then we've got the idea of a closed port. A closed port is one that's configured to reject or ignore the data packets that come to it. You can find out what ports are open or closed by using software like Nmap. So Nmap is a network scanner. It's going to go and it can do port enumeration. And port enumeration is the process of identifying which ports are open and closed. So what it's going to do is you give it an IP address and you can have it scan it. With Nmap, you can actually set different settings on there to be less obvious because scanning ports on a system, if it's not one of your systems, it's considered hostile. So you don't want to just go willy-nilly, port scanning somebody's server without permission. So keep that in mind. And also, the last thing we need to discuss is something that I talk about quite a lot. It's default passwords and unnecessary software. Always, 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 always change default settings. If you can change the default user for admin, change that. Change your default passwords. A lot of hardware that's out there ships with defaults for username and password, and you want to change that. When you get a Raspberry Pi or something like that, immediately change your root and your password on there, because if people are able to hack in, then or if people get a hold of your hardware, or if they can connect to it and they know what the default password and username is, they can get access and do all kinds of bad things. And I've shown you in class too that you can go and just do a simple, let's say you're talking about network router, you can go in and type in default username and password for Netgear, whatever the model number is, and it'll tell you what it is. And you can use that information. And a lot of people are able to get into systems, even in industrial, industrial organizations. People have been able to break in through these default usernames and passwords that are left as is. So always change that. Another thing you should do to harden your endpoints is to remove any unnecessary software. Computers these days, when you buy them, they come with a bunch of stuff we call bloatware. And a not so nice name for it is crapware. But you want to remove everything that you're not using on there. Number one, it's going to improve your efficiency. It's going to make your system faster, more efficient if it's things that are running by default. Take off all the unwanted stuff. Also, it reduces vulnerabilities, because let's say it's a piece of software that you never use, and over time, let's say there are vulnerabilities that are discovered in this thing, but you're not using it, so you don't think to update it, and it's just sitting there as a vulnerability. So if you're not using it, just remove it. If it's not something you think you'll be using, remove it. Unnecessary software, just get rid of it. It's vulnerability and it's going to slow down your system anyway. So, or possibly slow down your system. So that's it for this lesson. To recap, we talked about data encryption, we talked about the hard disk, we talked about using full disk encryption or self-encrypting drives. We want to keep in mind that both of them use AES and both of them use AES with 128 or 256-bit keys. Full disk encryption also uses a cipher block chaining mode. In doing that, remember that SED is fully, encapsulated, so you don't have to worry about, software doesn't have to worry about, interacting with it. You just treat it as a drive. You don't have to do anything special. It's all self-contained. All the hardware does all the work for you. Remember that Opal is the set of security specifications for SED. They define the processes and everything else. It's set. The specifications are set by the Trusted Computing group, the storage work group. And also keep in mind that we have this thing called the registry in Windows. Registry is where all these configurations are stored, usernames, passwords, things like that. We want to control access to it. In order to harden endpoints, we want to control access to it. So we want to limit that through a group policy object setting. And that's, you dig down through user configuration, administrative templates, system, prevent access to registry editing tools. Set that so that only administrators, you enable that so that only administrators can access the system, the registry. And then we talked about the open ports and services. So we've got well-known ports, registered ports, and higher number ports. Ports are either open or closed. We can enumerate them, which means to discover what's open and closed using tools like Nmap. And we want to close all these ports or services that we're not using. We want to turn those off so that we're not worried about, so that we're not actually exposing our systems to unnecessary, threats. And we talked about changing default passwords and removing that unnecessary software. So that's it for this section. If you have any questions, feel free to reach out. Aloha.